Hello, and welcome to Human Anatomy Prep. I'm Ty Gardner, and I'll be your instructor. This is a short chapter, so we have what I hope is a simple mind map. First, we want to know where the spinal cord is located. Then we'll want to take a look at the locations of different kinds of neuron cell bodies. This will tell us how signals travel through the spinal cord. A spinal cord reflex will serve as an example. Finally, we'll look at nerve plexuses, web-like networks of spinal nerves, and a few key nerves that arise from them. The spinal cord is located in the vertebral canal, the combination of all the vertebral foramina. The vertebral canal is part of the dorsal cavity, where we also find the brain in the cranial cavity. The spinal cord begins at the foramen magnum. Above here, we find the medulla oblongata of the brainstem. The spinal cord ends around the L1 vertebra, but it gives rise to spinal nerves further down the spine. The tapered end of the spinal cord is called the conus medullaris. A strand of connective tissue called the filum terminale extends from the conus medullaris to the coccyx. But what is of more interest to us are the nerve roots that exit the spine below L1, the cauda equina. Cauda equina equals horse's tail, describing the appearance of the nerve roots extending from the end of the spinal cord. The spinal cord stops growing around 1 to 2 years old, so it doesn't reach the bottom of the spine in adults. Here we can see spinal nerves exit the vertebral canal through intervertebral foramina. Nerves of the cauda equina exit through intervertebral and sacral foramina in the same way. Okay, it's time to talk about the location of neuron cell bodies. We need to know a couple of parts first. Here we see a section of spinal cord with gray matter in the middle and white matter on the outside. The gray matter looks kind of like a butterfly. Its wings are called horns. We identify up to 3 on each side. We already know that gray matter is where we find cell bodies in the CNS. The roots are where axons of spinal nerves connect to the spinal cord. They join in the intervertebral foramen. The dorsal root has a bulge, the dorsal root ganglion. We know that cell bodies are found in ganglia in the PNS. A spinal nerve carries axons from both roots. It splits into 2 branches, the dorsal ramus and the ventral ramus. The ventral ramus is the bigger of the 2, and will contribute to the plexuses we'll talk about later. The dorsal root ganglion is where we find the cell bodies of sensory neurons. Sensory neurons have kind of a funky shape, with the axon extending both directions from the cell body. So the dorsal root consists of axons of sensory neurons headed to the dorsal horn. Interneuron cell bodies are found in the dorsal horn. They receive sensory signals from sensory neurons. In a simple version of a spinal cord reflex, the interneuron carries the impulse to the ventral horn. Somatic motor neuron cell bodies occur in the ventral horn. They receive motor signals from interneurons. Motor signals, somatic and autonomic, are carried out through the ventral root. A spinal cord reflex arc might look like this. This assumes motor output at the same level of the spinal cord. Autonomic motor neuron cell bodies occur in the lateral horn. Like somatic motor impulses, autonomic impulses exit on the ventral root. However, this diagram is missing things. Sections of the spinal cord that generate autonomic impulses, T1 to L2 and S2 to S4, have 2 extra branches, called communicating rami. These carry ANS signals to and from the spinal nerve. We'll learn more later. Okay, we've seen where cell bodies and axons are located, but what do spinal nerves do? Spinal nerves carry motor impulses to effectors and return sensory signals to the CNS. Axons from different spinal nerves combine in net-like plexuses to form nerves serving specific regions. The cervical plexus consists of axons from C1 to C4 spinal nerves, with a little of C5. One major branch of the cervical plexus is the phrenic nerve. It innervates the diaphragm, our primary muscle used for breathing. Therefore, a spinal cord injury in the cervical region may result in the loss of the ability to breathe on your own. The brachial plexus, consisting of axons from C5 to T1 spinal nerves, gives rise to many nerves of the arm. One major branch of the brachial plexus is the median nerve. It travels down the forearm and through the carpal tunnel, under a band that holds tendons near the wrist. Carpal tunnel syndrome can result in tingling in and loss of use of the thumb, index, and middle fingers. The lumbar plexus consists of axons from T12 to L4 spinal nerves. One major branch of the lumbar plexus is the femoral nerve. It innervates anterior thigh muscles, for example, the quads, but receives sensory signals from as far as the medial foot. The sacral plexus consists of axons from L4 to S4 spinal nerves. It gives rise to the largest nerve in the body, the sciatic nerve. It runs down the posterior side of the lower limb. The sciatic nerve innervates posterior thigh muscles, hamstrings, and the crural region, below the knee. I hope this has been helpful. Your next stop is the video on the brain and meninges.